Okay, this is my program here that I use to create Halauto, and there's a whole mess of programs here, you know, small source files, and you can see when I click, it opens up forms and stuff. So this is where I do most of my work in C++. So I'm going to start it up, and I'm communicating to an Arduino through a serial port. So I've got 3 schematics. I'm going to click on Activate Motors because I want to show you how this works. This is the Arduino control, and it goes through a serial port. And I think I've got the serial port set for the USB 0. And already you can see it here rolling through, talking to the Arduino. I'm going to click on the Arduino, and you can see that I've added. I can just add a pin here and tell it what it is, and connect up to the control here. These are the controls that this Arduino is connected to. It's these guys right here. You can see them right here, like primary arm move placeholder, primary arm move placeholder. And what the schematic does is I have a startup pulse. So when you click on this, after this program, the program Halauto starts, 5 seconds afterwards, a pulse is sent out. Let me shut down this Arduino here real quick. There you go. A pulse is sent out to these 4 controls, which eventually get up to the motor. So they're just constant that are set to true, you know. I'll put a true. And a true actually, strangely enough, disables the stepper motor controllers on the aquaponics or the hydroponics unit, robot unit. So I have 4 controls: up and down, horizontal movement of the whole unit, primary arm and secondary arms, which go all the way into position themselves above a plant or a hole in a pipe that the water runs through, and then it can position itself. But here what I do is at startup, after 5 seconds, I send a true through this guy and this guy into the Arduino. And what that does is it sends you can see right here, values are, you can see this, there's a receive and a send here to the Arduino. And after startup, it sends a true into all the motor drivers, which disables the motors, because stepper motors take power when they're running. When they're not even running, they take power, and it takes about an amp at 24 volts to run to keep it fired up all the time. So if you have 4 stepper motors, there's 4 amps being used when they're doing absolutely nothing. So I disabled them right at the start. That way, and plus they run a little hot, and I don't need any extra heat. So that's the purpose of these constants here. That's what they are. There's a constant that outputs a true whenever it gets a signal from this guy. So it's hits this guy, sends out a true, goes through this is a many to one. You can see the little face here. Anyway, the picture, on the cube is significant of, it's significant of the fact that many inputs go into one input. And one of those inputs will be, the control where I enable, set the direction, and then move it. So These are placeholders which you need to talk to the Arduino. And I'm not going to get into why, but they are there. So I can actually go into the secondary arm direction here and click on it and either send it on or off, and that will set the direction of I think I can actually show that. So let's primary arm direction placeholder. Let's send a true out to that, set to on. And you see there's a 1 right there. Got sent to the primary arm direction. And if I send a 0, boom, it sends a 0. So it shows the fact that I sent it out, change the direction of the motor. And then here are inputs coming in and analog in that show the primary and secondary arm positions. So everything is working now as far as all the motors, so except for the horizontal motor, which I can't move that in my office because it's not, it's tied down right now, not to be able to move. So but I can position the up and down and position the primary and secondary arms. So I'll make I'll put up some pipe in the office here and go ahead and have the primary and secondary arm position themselves. Anyway, so that's the way it works. This many to one that's here is what I'm going to send information through to set direction and enable and disable all the stepper motors. Over here is on these yellow ones here, you can see an arrow that says I'm going out, and this little representation here is an analog representation. This 1 0 is a digital, just on and off here. See that? On and off. So yellow is analog, and on and off is 1 and 0s. And you can see that they're all set to true. That's what went out last time. And I sent a 0 out here on this guy, so it's blue. So red is on, blue is off. And is there anything else I need to show? But anyway, so this works, and this is the way I'm going to control it. Also, you can probably see if I click on this primary arm move placeholder, did it come up? No, it didn't come up. Let me click on it. Or did I? Yeah, it's already up. Yeah, I should set the focus on that form whenever I click on it, because it was underneath this Arduino. So I have the ability to fake an input. Later on it'll be fully automated, but I can fake an input, and when I fake an input, see, it sends it over here. You can see that it sends it. And anyway, it's disabled, so it's not going to turn right now. Still gets the amount of steps. I think there's 1,600 steps for each revolution is the way I've got it set. And this Arduino control right here that's communicating with the Arduino is going through it communicates with this program, this main program here. And this main program, you can do all kinds of different stuff, like the one-wire temperature system, an ultrasonic sensor, servos, analog in, analog out, etc., etc., etc. I've got it set to use analog in and steppers. And when you undefine these right here in your Arduino control and send that into the Arduino board, the chip will do these particular functions. Now if I go ahead and look for that, find it, you'll see that I have whenever the Arduino is looping, hang on a second, yeah, here I'm setting the structure that does the takes in the information of what I want Halauto is sending, and it stores it in here, and then it's able to run and do whatever it is that I want it to do. So right now I've got 4 stepper motors. So on pin 2, pin 5, pin 8, pin 11 is the beginning move pin, and then 2, 3, 4 are the 3 pins used. 3 and 4 are direction and enable. Same here. 5, 6, 7 is 6 and 7 are direction enable. 8 is direction enable. 11 is direction enable. And if I keep finding this define statement, I'll find in a loop, it simply runs through this little routine here, where it takes the amount of steps and just keeps firing one step at a time, and it'll write to that current single step pin, which is in the array that I showed, one of the 4 arrays that I showed you. 4 structures set this particular pin. So anyway, I think this is quite an elaborate program, but most of it is not used whenever you define or undefine a particular part. Then only a certain amount, only that certain part will be compiled and sent into the Arduino. So it makes it very efficient. So not every single thing that this program can do is sent to the Arduino. You define them out or define them in, you know. So anyway, this is how many things that I've got programmed in there, and Halauto communicates with this main program. And the way it communicates is at startup, it will send all this information through this control into the Arduino chip, and now it'll do this communicating right here. Where you can see it actually, you know, send on this USB port, primary in position, the actual values that are being sent, the amount of time, the wait, how long it waits, etc., etc. These right here are just LAN or IP addressed cameras that I've disconnected, because I don't use the positioning system on those anymore. So that's it. Let me see if I can go ahead and shut this off here. Oh, there it is. And I'm done.